Let's go to page 267. Start with number 1. Okay, you have square root of 52. So simplify, you need to go ahead and break it down. So divide by 2, it's evens, divide by 2, you get 26. Divide by 2, you get 13. So these are square roots, so you need to get 2 of the radicand to make an integer. So these 2 radicand will give you an integer. This is the leftover, so it will be square root of 13. Okay. Number 3, you have square root of 162. You can go and break it down. So it's an even, so divide by 2, so you're going to get 81. And the sum of digit is multiple of 3, so you can divide by 3, so it'll be 27. Divide by 3, you get 9. Divide by 3, you get 3. Now to be safe, it's probably better to just go and keep all the way down when you get to 1. Okay, so square root means you need to get 2 radicands. So these 2 radicand will give you an integer. This 2 radicand will give you another integer. The leftover will give you the radicand. And so this will equal to 9 square root of 2. Okay, number 5, you have square root of 196. Okay, so you can break it down. Divide by 2, so you always start with the lowest prime number. So divide by 2, okay. Divide by 2, and this becomes 7. Divide by 7, you get 1. Okay, so these 2 radicands make an integer. These 2 radicands make an integer. And that's not leftover, so answer will be equal to 14. Okay, number 7. So again, I'm going to separate the top from the bottom already. So instead of copy the problem exactly the same, I'm just going to separate the top from the bottom. So we can do the top and bottom individually. So 8 divided by 2, you get 4. Divided by 2, you get 2. Divided by 2, you get 1. So square root means you need to get 2 radicand to make an integer. So these 2 radicand make an integer. This is the leftover, so it stays inside. Okay. And on the 9, okay, you divide by 3, you get 3. Divide by 3, you get 1. So the 2 radicands make an integer. Okay, and that's it. So again, you go off to the side to simplify each part. And then after you write it down, if you can cancel, you can cancel. If not, then that's it. Okay, number 9, you have square root of 4 over square root of 3. Okay, so this will equal to, so simplify each part first. So 4 divided by 2, you get 2. Divided by 2, you get 1. So 2 radicands make an integer. Okay, but now you cannot have the square root in the denominator, so you need to get rid of that. So you only have 1 radicand, so you need to get 1 more. So you can remember 2 radicand make an integer. Now since you multiply by a radicand, you need to multiply the same on the other side, or on the top. So on the top you get 2 square root of 3. On the bottom, again 2 radicands make an integer. Number 11, you have 4 over square root of 2. Okay. So you have square root on the denominator, so you need to get 1 more radicand. You need 2 of them to make an integer. Now because you multiply this on the bottom, you have to multiply same on the top, so you're not changing anything. So this one becomes 4 square root of 2 on the top. Now 2 radicands make an integer. Okay. So these 2 radicands make an integer 2. And then 2 and 4 can cancel out, can divide by 2. So your answer would be just 2 square root of 2. Okay, so you got square root of 270 over square root of 6. Okay. Now, whenever you can cancel, you want to go and cancel as much as you can, unless it's a perfect square on the bottom. Okay. If it's a perfect square, then you don't want to mess with it. But right now, this is not. So that's going to reduce. So this is even, so you can reduce by, both of these are radicand, so you can use radicand, cancel with a radicand. Okay? And see over here, the integer cancel with integer, right? You cannot cancel this with that because this is a radicand, this is integer, so they are not the same, so you cannot cancel these 2. Okay, so divide by 2, you get 3. Divide by 2, you get 135. And this one still can cancel. Divide by 3, you get 45. And so this becomes, so the bottom is gone, so it's 1, so you don't write anything, so it becomes square root of 45. Okay? Now you can go and simplify this. So 45 is much easier to do than 270. So you want to reduce as much as you can. Okay, so divide by 3, you get 15. Divide by 3, you get 5. Divide by 5, you get 1. So you need to have 2 radicand to make an integer 3, and the leftover stays inside. Okay? And so that's it for number 13. Okay, number 15. Okay, you got square root of 30 times square root of 42. Now, instead of multiplying into huge number, then you reduce. Sometimes it's probably a little bit easier if you just go ahead and break down into parts. So 30, you can break down into 2 times 3. I break it. So this is what you do. So you get 30 divided by 2, you get 15 divided by 3, you get 5 divided by 3. Divide by 5, you get 1. Okay? And so 42, so you want to break it down first. So 42, you get 21, divided by 3, you get 7, divided by 7, you get 1. So when you multiply all this together, so this is 235, okay? And the 42 is 237. Okay? So now you can go and collect this together. So you can see that these two will give you a 2, right? This 2 radicand will give you a 2. This 2 radicand will give you a 3. And this cannot, so it will be square root of 35. Okay? So again, what you want to break it down first, and then from here. Now, when you break it down, you don't have to do this. Okay? You can skip this step, but I'm just showing you so you can follow. You can just go and collect this over here. So again, these 2 radicands will give you integer. These 2 radicands will give you this integer. These are left over, so you get that. So answer equal to 6 square root of 35. Okay, so you got square root of 6 times square root of 2 over square root of 3. Okay, you can separate the top and the bottom. Now this one, the 3 and 6 can cancel. Divide by 3, you get 1. Divide by 3, you get 2. So now you got square root of 2, square root of 2. So you got 2 of the same radicand, we're making the integer 2. Okay. So you can cancel, reduce. It's much easier to do than multiply out and make a big number. Okay. And then you have to reduce, more work. You have cube root of 250. So you go off to the side, so you got 250. You can start with 2. So this is an even number, so you can divide by 2, so you get 125. Then you can try the 3. No, it's not going to work, so 5. Again, you try the prime numbers. So you try the 5, you get 25. Try 5, you get 5. Try 5, you get 1. Okay, now, index is 3, means you need to get 3 radicands to make an integer. Okay, so this 3 radicand give you an integer 5, and this is the leftover, so it stays inside. And remember, this is a cube root, right? It's not a square root. So you have to pay close attention to the index. Okay, so again, this is a cube root of 5 over cube root of 4. Okay. So again, separate the top from the bottom. Now notice this, the bottom is the 4 is equal to 2, right? So this is cube root of 2 times 2. Okay. So cube root means you need to get 3 radicand. Now you got 2 of them, so you need to get 1 more. So you need to get 1 more cube root of 2. Now because you multiply by cube root of 2, you need to have cube root of 2 on the top also. Okay, so now you got 3 radicands. You got here, you got 1, 2, 3. So you got 3 radicands. It become an integer. Okay, and these are radicands, so you can multiply, so it be cube root of 10 over 2. Okay, so pay close attention to the index. number 23, you have 9 square root of 2 over square root of 18. Okay, now notice you got 2 and 18 now. Remember, you only can cancel the same kind of number, right? So cancel only the radicand with a radicand. You cannot cancel these two because this is the integer, this is a radicand. So you can cancel, you get 1, and this becomes 9. Okay, so on the top you get 9. Now square root of 9 is equal to 3. Okay, and so now you can go and cancel even more. So divide by 3, you get 1. Divide by 3, you get 3. So answer equal to 3. Okay, so you got 2 square root of 7 square. So you have to apply the power rule to each part, right? So 2 square will give you 4. Square root of 7 square will give you 7, right? So this part give you that. So you can square that, you get that, square that, you get that. And so this will equal to 28. Okay, to page 268, number 27. You have cube root of 45 times by the cube root of 12. So you can, what you want to do, instead of multiplying the big huge number, go off to the side and simplify each part. So 45, you can divide by 3, become 15. Divide by 3, you get 5. Divide by 5, you get 1. So this one is this one here. Now for the 12, you do the same thing. Divide by 2, you get 6. Divide by 2, you get 3. Divide by 3, you get 1. Okay? So once you break it down, now all these are cube root. Means you need to get 3 of them to make an integer, right? So notice you got 1, 2, 3. So this 3 will give you an integer 3. And that's it. So you only got 2 of these, you only got 1 of these, right? So you don't have enough. So these are left over, these are to stay as a radicand. So just go and multiply out. So 5 times 2 is 10, times 2 equal to 20. Okay, and that would be it. Okay. So you can go break it down first and then collect your radicands. So you can cube root means you need to get 3 of them to make an integer. Okay, next one, number 29, you got cube root of 60 over cube root of 36. Okay, so again, whenever you can, try to reduce as much as you can. Okay, so all these are multiple of 6. So divide by 6, you get 10. Divide by 6, you get 6. Then you divide by 2. Divide by 2, you get 3. Divide by 2, you get 5. So this becomes cube root of 5 over cube root of 3. Okay? So now you have to get rid of the radical in here. Okay, so index 3 means you need to get 3 radicands, okay, to get rid to make into an integer. You only got 1, so you need to multiply by 2 more. Okay? So you need to get 1, 2. You need to get 2 more. Right? So you have to do the same thing for the top. Okay. So now you got 3 radicands. So 3 radicands you can make into an integer. By cube root means you need to get 3 of them. Okay. Now for the top, you just go and multiply, right? You have nothing to make an integer. So 3 times 3 is 9, times 5 is 45. Okay. Okay, 31a, you got square root of 32. So you can go up to the side. So 32 divided by 2 is 16. Divided by 2, you get 8. Divided by 2, you get 4. Divided by 2, you get 2. Divided by 2, you get 1. So square root means you need to get 2 radicands to make an integer. These 2 radicands to make an integer. This is the leftover. Okay. So again, this is here. This one is this one, and this one is here. Okay. And so this will equal to 4 square root of 2. 31b, you have cube root of 32. So do the same thing. You got 32 divided by 2, you get 16. Divided by 2, you get 8. Divided by 2, you get 4. Divided by 2, you get 2. Divided by 2, you get 1. Now index is 3. Now instead of 2, right, over here is 2, but over here is 3. So you need to get 3 radicands to make an integer 2. And this is the leftover, so it'd be cube root of 4. Right? 2 times 2 is 4. Okay? And so if you write it better, get rid of parentheses. Okay? Okay, 31c. Now you got 4th root of 32. So you can use 32, so divide by 2. 16 divided by 2 you get 8, divided by 2 you get 4, divided by 2 you get 2, divided by 2 you get 1. Okay, so now the index is 4, means you need to get 4 radicands to make an integer. So this will give you integer 2, and this is the leftover. Okay, so you can notice the difference among them. Okay, okay, 31d. Okay, you got 5th root of 32. So you do the same thing, right? Divide by 2, divide by 2, keep going, break it down. Okay, now index is 5, means you need to get 5 radicands to make an integer. Okay, and that's not left over, so that's it. Okay, so you can see the difference among the different index. Okay, so this is square root, index is 2, 3, 4, 5. Okay, 33 equals square root of 39, and this one they use the calculator or table 1. So if you use calculator, much easier. Okay, so just go 39 and you push the square root button. Okay, so this and it says nearest hundreds, right? So this is equal to 6.2449 whatever, right? So hundreds is right over here. So you have to look at the digit after that. If it's 4 or less, you chop it off. It's 5 or more, you round it up. So this will equal to approximately equal to 6.24. Okay. Okay, number 35. You have cube root of 450. Okay, so get a calculator. So 450 cube root. Okay, so this is equal to 7.66309 again to hundreds. Okay, so this is less than 5, so you can just get rid of that. So whenever you chop off digits, it becomes approximation. So this approximate equal to 7.66. Okay. Okay, 37. Okay, you have 4th root of 144. So you can get your calculator. So 144 and 4th root. Okay, so this is equal to 3.4641 dot 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 dot, right? Again, you want to run it off to the hundreds digits, right? Okay, so again, this didn't make a 5, so you just chop it off, right? Again, if it's 5 or more, you run it up. So this is about 3.46. Okay, number 39. Yeah, square root of 18x squared. So when you have variables, what you do is just focus on the number for now. So 18 divided by 2, you get 9. Divided by 3, you get 3. Divided by 3, you get 1. So this part, so for the number, okay, the 3 will come out, and the 2 left stays inside. And the x squared, square root, this will cancel out, so you get x. But remember, okay, so this will give it absolute value, because whatever x is, you have to square that first, so it becomes positive. So when you take a square root of the positive, it's always positive. So remember this part over here. And then after that, normally you write a square root on the end. It would be 3 absolute value of x, square root of 2. Okay. Okay, again, you do this absolute value only if you have the even exponents. Okay, you have the cube root of 375 a to the 5. Okay, so 375, again, let's go off to the side. Okay, so you cannot divide by 2. How about 3? So if you add the digits together, 3 plus 7 is 10 plus 5 is 15. So sum of digits is 15, so divisible by 3. So divide by 3, you get 1, 2, 5. And now that's it. So now you go for the 5. So you get 25. Divide by 5, you get 5. Divide by 5, you get 1. Okay, so now, again, the index is 3. So you need to get 3 radicals to make an integer. So this will be 5 cube root of 3. Okay, now a to the 5. So again, you can go off to the side to do the minus step. So this is equal to cube root. So you can break into a to the 3 and a to the 2, right? So there are 5 of them, so you get 3 over here and 2 over here. And this will give you a, right? And cube root of a squared. So the a comes out. So this will become a cube root of a squared. Okay? And after that, you go and tidy up a little bit. So it'll be 5a cube root of 3a squared. Okay? So you have to combine this into your radicals. Okay, number 43. Okay, I'm going to start with the top and the bottom. Okay, again, to save you some time. Okay, so when you simplify this part, so this will give you x, and remember the absolute value, right? Because it starts with a square. Now the y cube, cube root of y cube, square root of y cube, you can bring to square root of y squared and square root of y. Okay, so you always break down as much as you can so that you can take it out. So when you take it out, you get y, and this would be square root of y. Now you don't need to have absolute value because you start with a cube. Okay, so you start with a cube. Okay, you only have absolute value when the exponent is even, like 2, 4, 6, 8, right? Okay, so now you have to get rid of the square on the bottom. So you need to multiply by square root of y, square root of y, because you need to get 2 radicals to make an integer, right? Okay, so this comes, so you end up with a y squared, and on the top you get absolute value of x, square root of y. Okay, number 45. Again, I'm going to separate the top from the bottom. Okay, so let's go and simplify each part first as much as we can. So 27, you can divide by 3, you get 9, divide by 3, you get 3, divide by 3, you get 1. So index is 3. So get your fraction ready. So index is 3 means you need to get 3 of them to make an integer. So this come out nicely. And this is the leftover. You cannot do anything with it, so just leave it alone. Right? Now on the bottom, okay, you got cube root of 4b to the 4. Okay, so this one can break it down. So you can have cube root of 4, and then you have cube root of b to the 3, cube root of b. Right? So this can come out. So it becomes cube root of 4. B, and this come out to the, so this comes out to the front, and this stays inside. So go up to the side, simplify as much as you can. Now for the 4, I'm going to write down as 2 times 2. Okay, I'm going to break down the 2, 2b. Okay, so because the 4 is 2. The reason I need to break down so I can see how many radicals I have and how many do I need. Okay, so to simplify the square root, okay, I need to have cube root of 2. I need one more 2, right? I got 2 radicals, so I need one more. Okay. Now over here, I only got 1 radical, so I need to get 2 more. Okay. Okay, so I need to do the same thing over here. So the cube root of 2b, right? So again, I need to get 3 radicals to make an integer. Okay. Okay, so I'm going to take out the bottom first. So I got b already, and these 3 radicals will make an integer, right? And this 3 radicals will make another b. So I'm going to just write it over here. So this b came from here, and you got another b, so that's square, right? On the top, okay, your integer 3 and your radicands are all these, so it would be 2ab squared. Okay, so you got 2ab squares. And that's it. Okay. So again, you have to keep track of your index so you know how many radicands you need to make an integer.